Welcome to DevOps and Docker Talk, and I'm your host, Bret Fisher. I'm a Docker captain, a cloud native ambassador, and I create cloud native DevOps content. This week, I'm with my co-host, Nirmal Mehta of AWS, and our guest is Maria Vechtomova, joining us to discuss how DevOps engineers can adopt machine learning workloads and operate them. This is also known as MLOps, and Maria is a MLOps Tech Lead at a multinational retail and wholesale company and the co-founder of Marvelous MLOps, which creates educational content on Substack, LinkedIn, and other internet places. This live stream was popular with our chat audience this week, who had more questions than we could have answered in an hour, largely focused on how a DevOps professional implements ML workloads and how to get started learning MLOps. Maria had lots of great answers and even a few hot takes, including how they're using Kubernetes. This is an edited version of our weekly YouTube live show that you can join and ask our guest questions on Thursdays at 1 p.m. U.S. Eastern at bret.live. So please enjoy this episode with Maria of Marvelous MLOps. Maria, thank you so much for being here.
Thank you so much for having me. I really love your show. So looking forward to a great conversation.
I'm glad to have you.
Where do we start? MLOps is like a universe of a topic, right? Like it's massive.
Yeah,
so.
Rita, how did you get your start? Like, how did you get into MLOps?
That's a good one. Yeah, I'm in data and AI for over a decade, and I started as a data analyst. I actually studied economics, econometrics, so I wanted to do something with the data. I really liked programming in R, so data analytics was a choice that felt natural to me. Then I moved into data science. And very fast, I understood that when you have something working and you want to put it in production, there was no one who could help you to do that. So we started figuring it out on ourselves, started bringing DevOps practices into machine learning field, which was not done back then. No one was using CI/CD pipelines. There was no version control, no orchestration, nothing like that. And we just started introducing it to fellow data scientists and analysts to automate their workloads. We also built our own experiment tracking system and a model registry. We built the whole MLOps framework with different tools all over again 4 times. So yeah, I have a feeling I've seen it all. I used also really cloud native approach. So we were deploying jobs on Kubernetes, deploying our endpoints on Kubernetes, but also AWS. And now I'm using Databricks a lot. Basically, it came from the need that there was no one who could help us to do that. So I just started doing it myself, and that's what I enjoy doing the most.
So really learning from getting hands-on, like the need to solve those problems, just figuring it out in real time, figuring out what you needed to learn to solve that, whatever that problem at the time was, correct?
Yeah, exactly. Because it was very hard to bring anything to life, right? When you had machine learning model, you had some output. That output had to go to some system. It had to go via emails, but how do you deliver it in the first place?
Yeah.
You need to go and talk to different departments in the organization. How do you do that? And then learn from them, learn from other DevOps engineers as well. Because, the large organization, they already have these tools. They already have version control. They already have something for CI/CD, for orchestration. So we had Airflow, we had Jenkins back then. We had our code on Bitbucket. And we also had Kubernetes as a service. So that would happen to be the place for us to deploy things. We had Elk Stack, which we were using for monitoring Grafana. So just by figuring out what's out there, we just got to that place.
That's a lot. That's a big list, what we just talked about.
Yes.
In fact, in the recent KubeCon in Paris, like they had an entire day's keynote dedicated to just everything Gen AI, machine learning, like the whole stack. And there was I specifically remember a diagram that I haven't seen actually anywhere else, but it had a lot of dots in a circle. There was maybe 100 or so. And I think they were all products or tools related to AI stacks and ML stacks. And of course, Kubernetes was one of those dots. And then it showed all these connections between how they're all related. And I thought, who can know all those things? That's all I could think of. Was like, there's too much there.
No, you don't need to know all of that. So there is, I don't know whether you have seen, there is Mad Landscape. You can search for it. It's called Mad Landscape. It's a machine learning and analytics data. That's crazy. The amount of tools that is there, like growing every year, and they release this thing every year. like unbelievable. And yeah, you can't learn all of that, obviously. And the tools itself change all the time. So you're using one tool, and in 2 years, it's a completely different tool. You have to migrate anyways. So it just never stops. But I think what's important to mention, it's not about the tools, it's about the principles. And that's what I feel is the most important piece. It's just like DevOps is also about the principles that you have. You need to make sure that there is traceability and reproducibility of whatever you do. So when you have a machine learning model deployment or run, you need to know where a certain prediction came from. What data did it come from? What model artifact it came from? What code did it come from? And also whether there were any changes in the data, like data drifts, model drifts in the past, so that you could track things back. And it's basically about connecting the dots and monitoring all of that. And just to make it happen, it's a lot of tools. And if I just look at the buckets of the tools, so you have version control, obviously you need that, just as in DevOps. You have CI/CD tools, you have orchestration tools, you have tools for compute, like where you train your models. You have tools to package your model. You have model registries, experiment tracking systems. You have serving infrastructure, where do you actually serve your models? And it can be Kubernetes, it can be many different places. It can be proprietary tools as well. Also, feature stores became popular recently. You also have now, with AI hype going on, you have vector search really gaining popularity, vector databases, and all kind of human-in-the-loop system, foundation model APIs. It's a lot. It's getting even more crazy than it used to be.
That is a lot. And so can you just step us through, just maybe at a higher level, what's the kind of steps? How do you interact with these systems? I want to put myself in your shoes as a data scientist or an ML engineer. What's my routine? How do I interact with these systems, and what am I doing? Because I think, our audience, and I can speak for myself, I'm used to, what a developer is doing on a day-to-day basis, and also what an operations or SRE person is doing on a day-to-day basis. But conceptually, what's the difference there? What's a ML engineer doing, and how are they interacting with these systems?
Yeah. Well, I think fundamentally there are different roles that are related to machine learning. So there is a data scientist, and it can be the data science only kind of do research or do modeling. If you have good MLOps system in place, like self-service, you don't per se need ML engineers. Ideally, data scientists would be able to deploy things themselves, but they need some kind of framework to make it happen. And that's something that MLOps is doing. They build a platform for data scientists to use. So it means that they have serving infrastructure as a service, reusable CI/CD pipelines, so that data scientists don't have to reinvent the wheel. Because I would say in a large organization, maybe 80% of use cases or more is exactly the same deployment pattern. It doesn't make any sense to go and reinvent how do you do authentication towards your compute, right? So it's the same types of problems basically that you have in DevOps, I would say. And also, that's just the DevOps part. And then there is ML part. How do you do ML monitoring? And depending on the type of model, monitoring would be different, like for recommender system and for classification tasks, or for demand forecasting, like regression type of tasks. Monitoring would be different. It's just different tools, and you can package it as a package, as a Python package that data scientists would be using to interact with other systems. So they could maybe send, log whatever they're doing using some tools, like we used to do it using Elk Stack. We had Elasticsearch Index. We were sending some information that we could then show on Grafana dashboard. So it really depends. I think MLOps is about connecting the dots and building tools that others can use so that they don't have to do it themselves. And it's about finding the patterns within your organization, like what is the commonality between all these things, I would say.
I had some assumptions. It sounds like, it feels like that the world of MLOps, the ops side of MLOps, right? So it feels very similar to what we've kind of done to ourselves over the last 15 years of labeling everything DevOps, when in reality there are roles. And it sounds like, you can have someone that's focused on CI/CD, but they maybe never manage the server infrastructure. You might have someone that's just a Kubernetes admin, and that's really all they're focused on. You might have someone that's actually managing all the AWS infrastructure that's underneath all that stuff. And we get what I call sort of these solo DevOps. That's someone that I have sympathy for because they're saddled with all of these responsibilities as if it's like one person's job. If someone's just sort of doing what I would call traditional DevOps in a small team where maybe they're using GitHub Actions for their CI pipelines, maybe they're using an EKS cluster for their regular workloads on AWS. And then there might be some data scientists that come with these new workloads. And I'm trying to imagine this scenario of like, how does a traditional DevOps person that's more on the ops side suddenly get saddled with machine learning workflow, not just workflows, but workloads? And how can they even tell the difference? How do they know that, okay, these are different things that I might need to do differently with? Are there particular tools they should be looking? Like if someone comes in and says Hadoop or some other random project term, is that sort of a indicator for, this is going to be a different type of workload that I might have to create different infrastructure for? Is it easy to pinpoint like that, or is it more complex?
I think it's a bit more complex. So I think if you just look at the Python scripts or whatever that you may have for standard DevOps or for machine learning, you would not see that much difference. It's more about the deployment patterns that you have. Like there are multiple types of deployment patterns like there is one standard one that is very similar, I guess, to DevOps. When there is a machine learning training process and the training process writes to some database. And then there is an endpoint, an API that reads from the database and returns some results. Well, it is very similar to software engineering, and then DevOps person doesn't have to do anything different because the monitoring side would be on ML people. Like it's totally detached. So then DevOps person wouldn't have to worry about those things. It's completely on ML side to monitor these things and update values in the database when they think is needed, right? Then there are other types of workloads, which is completely different than what DevOps might see. So one of them is when you just have a model artifact behind an endpoint. So actually, when you call an API, a computation is happening, and there is a prediction that is generated from that model artifact. And that's like a very different type of situation because nothing has changed, like nothing. Model artifact is still the same, but results are shitty. It just doesn't work anymore. Like that never happens to a normal DevOps scenario, right? Because nothing has changed. Code hasn't changed. Model artifact hasn't changed, but model doesn't produce any meaningful results. How? Yeah. And then in this kind of scenario, I think DevOps person needs to monitor, the model, whether there is a data drift or model drift. Then it's a DevOps person problem probably if there is this type of workload happening. So that's another scenario, which I think is very different from a standard DevOps approach. And then we can go even more complex than that. When you have real-time features, when there is some stream where you need to read the data from to actually make the predictions. And it can go different routes. Feature stores, I think, are quite great for that. So in feature stores, you could, put the real-time features. They all support it nowadays. And you can read from the feature store the values that you need to generate a prediction. Let's say when you call an API, you just pass a customer ID. But customer ID is not enough to generate the prediction. You actually need some details about the customer, like the age of the customer, what other pages did the customer visit. And this information is updated real time, and then you can get it from the feature store. So in this scenario, actually, DevOps engineer would need to understand how the feature store works and what can go wrong there. So there is different type of monitoring that needs to happen in that kind of scenario. Or maybe there is Kafka involved. I don't know. It depends on your infrastructure, on your setup. So this is just two scenarios that I mentioned that require very different approaches from a DevOps engineer than more like a standard batch process. So when there is batch, I don't think it's a problem of DevOps. It's a problem from ML team. But when there is something beyond batch, it becomes a problem for DevOps engineer, and they need to understand different pieces involved.
Right.
Yeah. So as I understand it, some ML workloads can look very similar to a typical web workload that a DevOps engineer is used to. But as these workloads get more complex, there's an additional layer of concern or area of interest or area of responsibility that the DevOps engineer needs to look at and be kind of operate due to the complex nature of that machine learning workload. And like whether it's real time, whether where the data is coming from, whether it's streaming, whether the prediction model is giving, needs to be monitored and observed in a specific way. And so it's not only a shift of responsibility, but it's additional responsibilities, because at the same time, they still need to look at, the CPU, the memory, the resources, the typical observability of that workload, in addition to these other responsibilities. Okay. Interesting. So it seems pretty intense. And I'm assuming that there's a lot of tooling around that to kind of help that DevOps engineer kind of understand what's going on at that machine learning layer.
Yeah, definitely. So I think there are quite some tools that can help you with observability. I don't know. There are some, well, mostly if you want to have some good features, it's all proprietary software, but you can run it. You can deploy it yourself on Kubernetes. So there are some tools for drift detection. I really like DanyML. It's open source. They have open source, but they also have like paid proposition. But open source, you could just deploy it yourself and use it to monitor model drift, data drift.
What was that tool again?
DanyML. Not many, like nanny, like for kids, nanny for kids. So, but it's nanny for models. DanyML. Very smart name.
Got it.
Bret, we've got a great list of questions queued up here. So should we start tackling some of these questions?
Yeah, I think the first one is, how do I transition from DevOps to MLOps? Does one need to know much about data science? I'm assuming this is on the ops side of things rather than on the science side of things. But
yeah. Well, I think it depends. So as I mentioned, depending on your company where you work for, it may be that you only have batch processes in place. Then, depending on your interest, you could maybe get involved into understanding what kind of monitoring the data science team is doing. Quite often, their monitoring is ad hoc. They don't really know the best practices for monitoring, so there could be a good addition. But if it's really towards model endpoint deployments, when there is actually a model that is computing something behind the endpoint, yeah, you need to know something about data science. I'm not sure how deep the understanding should be. You don't really need to understand, I guess, all the details behind the algorithms, how you actually build the algorithms from scratch. But you need to understand how the libraries work, probably follow a couple of courses on that, how all that work, what kind of tools data scientists use, but also understand how data scientists actually work. And the way how data scientists work may scare some DevOps engineers. So depending on the maturity of organization, you can see that data scientists use Jupyter notebooks and they don't know how to package their code well. Well, they don't write modules. It's just like one humongous Jupyter notebook that they ask you to put in production. You probably have heard of those. So I think it actually creates distrust between data science teams and DevOps engineers, because DevOps engineers, I guess, are more used to best coding practices, and data scientists, they are used to experimentation. And we need to find a middle ground. I think data scientists need to, there is still time needed to professionalize the field, and DevOps engineers could be very helpful in this process. Also, best security practices. And I don't know, I write quite a lot about security because I feel data scientists don't respect security enough. And I've seen a lot of bad things. So yeah, a lot still needs to happen.
Security is very tough. So, that's an evergreen topic of consideration and improvement. I really like your advice. It sounds like it would be beneficial for a lot of us, like DevOps practitioners, to put ourselves in a data scientist's shoes for a little bit and find like a little project or some, maybe a project to implement some kind of prediction model or some kind of model of some sort off of some open data, and like really step through the process of what it looks like for a data scientist to experiment and develop something that then will need to be trained on, a larger data set, just to get an awareness of the world that the data scientist is kind of living in typically.
But I think in general, so how did I learn about all this MLOps stuff? Like I just went to software engineers and I worked together with them. I asked them questions. And I think that's a universal way to learn things. Just talk to people. Talk to data scientists. If you want to learn data science, if you want to go into this field, just talk to them. You will see how their processes can be improved and they teach you what you don't know, right? It's like win-win situation.
So we got another question here. So how do you handle the trade-offs between model accuracy and computational efficiency?
Well, I'm not sure there is really such a trade-off, to be honest, because if you train model longer, doesn't mean it becomes better, right? It doesn't mean that. Also, if you make a bigger model, it doesn't mean it will become better. It will become more computationally expensive and longer to train, but doesn't mean it will become better. So I don't believe there is per se this trade-off here.
I completely agree. First of all, it's very unique to, there's no blanket statement. It's very unique to like the workload
Deep
itself,
learning.
right? The learning, the ML that's happening. I see also a trend, and maybe you see this as well, is that not as a trade-off, but like trying to find models that are good enough and also smaller that can run on maybe like CPU or other architectures just as a subset to get good enough for a specific use case. And so this is a very active area of exploration for sure.
And also, what is accuracy? I think it's just so wrong to think about accuracy. You actually need to think about business value. That's what you need to think about. And it probably doesn't mean accuracy in your case, because, the cost of false positives and false negatives, that's what you need to take into consideration if it's a classification task. And that's what you need to optimize for, not for accuracy. And that's, I think, what people often miss. They, chase some numbers, and those numbers sometimes don't matter anything.
That's a very good point.
Engineers be engineering, and we forget there's a business. That's a classic problem. Kind of a follow-up question. How do you address security concerns in MLOps, especially when dealing with sensitive data? I think that the sensitive data one might be a little bit unique because in traditional sort of classic DevOps roles, the stuff that we're usually dealing with that's sensitive, maybe a little bit of the source code, but also mostly just the secrets. And of course, now we have these secret storage systems, but they're just key values. They're short strings of text. The biggest we usually have to deal with is like a certificate in text. That's maybe the key. So what do you do about sensitive data?
Yeah, okay. What do we understand under sensitive data? Like if you talk about PII data that we use for model training, then you probably need to understand like who can have access to this data, really isolate the environments and have clear permission management for those roles. I think that's important. Also, I think there are different rules for different types of data. You probably don't need all these address details and things that are really sensitive. So you just need to make sure that you only use features that you really need for your model. Yeah, so I actually never had to use anything really sensitive. So I don't think in that sense it's very different from DevOps. I know we had some databases where we have PII data, so that we manage by isolating environments so that only very few people can access it, and we have clear controls in place. But I think that's as far as you can go with that.
Yeah, I was going to add on the sort of, I'm going to keep saying traditional DevOps side. Traditional DevOps, because I feel like eventually we're not going to be calling this MLOps. Like eventually I think it's just going to be ops. Like this is all ops stuff. It just depends. Like you have various workloads. But I feel like the trend is these tools are starting to standardize. Like maybe, tell me if I'm accurate on this. I'm sort of telling a story of like 10 years ago, 15 years ago, these were all specialized workloads with specialized tools. And as we started figuring out standard ways of deployment, like using Git for storing our infrastructure and deployment data, or our configuration rather, we started using containers, then eventually started using Kubernetes and orchestrator, and eventually Kubernetes got better at doing things like handling GPUs and large images and storage of volumes and backups and all the things that like standard ops people care about. Mm-hmm. Do you see where this is all sort of converging in terms of if someone asks for security, you're really just giving sort of an answer of standard DevOps of, well, let's have change control. Let's maybe use some GitOps or something where we're logging changes and we control access so that new versions of these different files are really all at the end of the day just files or data sources that we're controlling the change, logging the change for auditing. Does it become sort of similar once you've adopted a lot of these standard DevOps practices?
Yeah, I think there is a lot of similarity. I actually don't really see differences in those processes except maybe LLM endpoints. I think those need special treatment because, well, you can hack them in certain ways. You can let it say things you're not supposed to say. It can have actual business impact, like, selling a Chevrolet for $1. There was this kind of story. So it can say things you don't want them to say, and it can have actual business impact. So you could treat that as a security problem in certain sense that you don't really have traditional DevOps. So yeah, and sensitive data in those LLMs, like if someone is that you don't output anything sensitive because it was trained maybe on something sensitive. So how do you make sure that information is not included or that it never gets output to someone? Because there are a lot of different tricks how to make it say things. So you can maybe Google for it. There are different experiments people do. And of course, systems get better over time, but still people still are creative, They can figure things out.
That's a great answer. I feel like a lot of these it depends, but we're giving information anyway. Nirmal, real quick, I'm going to give you the next question. But before we do that, I feel like there's some questions that might be answered by a post you did earlier this year, at the end of last year. I just wanted to highlight this. This is, again, on your Substack. You can also find this in other places. So you can Google MLOps Roadmap. Maria, that's how I found it. Can you tell us a little bit? So people are asking a little bit about, like, how do I get started? What are common tools? What should I be looking? And you do a pretty good job of sort of breaking down what's the common languages, maybe the IDEs that you might be interested in if you're maybe more on the science side of it. And those of us in DevOps or MLOps, I figured, we kind of dance in the middle with a lot of things. So we might, like you said, sit down with some scientists. And if we're looking at Juniper notebooks, we might need to know what that at least is, or how they work, or how we put those into a server or into a container. And you mentioned things like Docker and Kubernetes. I did notice that you mentioned one of my courses. I just want to shout out. Thank you so much for that. Then you had some courses I was checking out before the show, Machine Learning Fundamentals, this mlcourse.ai, and then course.fast.ai, and some book recommendations. I mean, there's a lot of stuff here. So I don't know if you have an update to this or if more recommendations, but I just thought I wanted to shout out here for this. This is a pretty good article.
Awesome.
Well, yeah, machine learning fundamentals. For me, it's a bit hard to judge because, well, things that are obvious to me might not be very obvious to a DevOps engineer. In the end, I used to be a data scientist myself, so I kind of followed back then all the courses that were available. So yeah, as I said, it's hard for me to judge, but those that I advised, they do feel quite basic to me. So if you don't really have background in data science, I think those are great courses to start with. And I think what's most important is understanding the principles of MLOps. And they are quite different than the ones that you have for DevOps. There is quite some overlap in the tooling, but because there are just more components and the fact that the data can change and the model doesn't change and still things are still breaking, that's just such a fundamental difference that, just creates so much more overhead. And you just need to understand these small details, and that's why understanding the principles would be a good starting point. We also have an article about principles, like a checklist, what you need to have when models are in production. I need to find that link. But maybe it's also in here. I'm not sure. Possibly.
There's a lot to it.
Yeah, for sure. And the infrastructure as code, I feel, is also an important piece. But it's more like on a DevOps side, really. It's, I guess, depending on who you consider a DevOps engineer. But I believe like the whole permission management, it's just so important for machine learning workloads as well. When you have machine learning model endpoint, it's still like an endpoint, and you still need to manage permissions correctly. And the way how you connect your whole cloud infrastructure, how your groups of users are related to your groups to Teams and GitHub, for example, that you want to sync them, that you want to sync different things with each other. It's just the same thing that you have in DevOps. It's just now you have more components to sync. It becomes even harder.
So speaking of components, what are your opinions on using Kubeflow to build ML pipelines? Are there other platforms you would recommend?
Actually, I never use Kubeflow myself, so I can't really advise on that.
There you go. Which ones do you use?
Which ones do I use? So currently we use Databricks just because we happen to have it, and it doesn't make any sense to reinvent the wheel and go with other tools. But in the past, I used also SageMaker on AWS and the pipelines there. For orchestration, I used Airflow quite a lot in my career. But I guess a tool that is closest to Kubeflow, from my understanding, is Metaflow, that I also used for experimentation purposes. And I feel that's really like a nice way to orchestrate things. But yeah, there are just so many components, and I would say go with whatever tools you already have within your organization, because it doesn't make any sense to introduce even more tools and make your infrastructure even more complex. Just go with what you have.
I second that. I've seen customers use the Ray framework for their underlying infrastructure management, for the training and inference workload management, and then above that using, something like MLflow, which is different than Kubeflow, but for experiment management. And
the only thing similar about them is flow.
Yeah, there's a lot of tools that sound the same for sure. And it can be very confusing. But I think that the blog post that you just mentioned earlier, Bret, has a lot of these kind of, some of your recommendations already in there, right, Maria? Around like kind of what to kind of look into if you don't have a default or an existing tool that your organization is using.
So I think set of must-haves for MLOps, that's a great article. It's like under the roadmap that you like this one. So I was explaining like what are the pieces in MLOps which are important, and this diagram actually shows the tool belt. So you have just different tools for version control, CI/CD, orchestration, registry, container registry, of course, as well, compute serving and monitoring. And Docker is an important piece of MLOps, obviously. We use it. I always used it, actually, pretty much since the beginning of me doing MLOps.
Awesome. Yeah, we had this discussion out in Lisbon last week around, you mentioned the data scientists just working on their Jupyter notebook and having this massive monolithic Jupyter notebook and then throwing it over the fence to the DevOps team. And not knowing about containers and how we can communicate better as Docker captains and, operators to those folks and those personas to think about containers as something there that can help them take what they're working on locally or with a small data set and transfer it over to the training and inference stages as needed. I appreciate you putting that there.
Yeah.
And using it for sure.
There is a big wall of confusion, I believe, between these two groups. And I think it's a historical thing because the data scientists historically come from the business domain. They used to be analysts, advanced analysts, and then data scientists, and they belong to the business. And then DevOps belongs to IT. And the data analysts just never had the right permissions to deploy anything in the first place. And, if you want to deploy something, you need to submit a ticket and then wait for 3 months, maybe 6 months before it gets picked up. Yeah, it's just a very annoying process to go through. And I believe now we are converging to this way of working where data scientists are fully empowered to deploy things themselves, of course, with the, with some safety locks in between that are created by the MLOps teams. But I think it's very important to go there.
Oh my goodness, we have so many great questions. And these are all great answers. Let's see. Skills for an intern in MLOps. So I'm going to shortcut this one and just say we just showed this roadmap and a bunch of great articles. So I would say step one is check out all of her and her co-host, co-founder on the Substack or on LinkedIn. You can find a lot of these resources in multiple places. But I mean, there's just so much here that I feel like this is the basic reading that I would come to for a lot of this stuff. And then you list courses and other resources to start digging into. So I'm going to leave that with that because we're running out of time and we've got great questions. How are you preparing your MLOps practices to adapt to these future trends? So maybe that's a good segue to like, what do you see that's maybe new? I mean, it sounds like definitely today you've got Docker and Kubernetes are sort of pivotal tools. Do you see a lot of the ML workloads moving to Kubernetes? I keep hearing that at KubeCon, but I just don't have my own customers, so I don't have any unbiased evidence of what's going on. Do you see that?
Well, I don't know. I have a feeling that now a lot of enterprises kind of move to some certain platforms that they buy, like Databricks. I think is really getting big, and they have their own ways to to do compute and serving, and then we are basically actually going away from Kubernetes, if you ask us, me specifically.
Interesting.
We used to have Kubernetes deployments. We still have them, but we are moving away to Databricks native deployments instead. And they also, by the way, use Kubernetes in the background, but you don't feel it as a customer.
So you're not writing Helm charts or a bunch of Kubernetes YAML anymore?
I used to, yeah, but not anymore, no, because it's too hard for data scientists. You can't, it's very hard to make it easy for them to deploy. And basically, they always need an ML engineer. Unless you build some beautiful frameworks around it, it's still very hard, though. But with Databricks, you just call an API and you don't even have to specify anything. It just figures it all out for you.
Nice. Well, with Databricks, I'm guessing that there's some proprietary stuff there. But when I think of like traditional Kubernetes stuff, I'm writing either customized YAML or just straight up Kubernetes manifest or maybe Helm charts, and I'm storing them in a Git repo. And ideally, I'm automating that with something like Argo CD or Flux or something else. I mean, how does that sort of deployment model, if you're just talking to APIs, I mean, technically Kubernetes is just an API, but I know I'm thinking of the tools and the Git workflows. How does that change if you're using something like Databricks and you're sort of avoiding the inherent complexities of Kubernetes? How does that change?
Oh, it's much simpler, actually. So to deploy things to Databricks now, there is a thing called Databricks Asset Bundles. So it basically packages your Python code. It builds a package. You need to define PyProject TOML file requirements, but it kind of creates this package, builds a big package for you, puts it on, on their workspace location, and you can define a job there. And job is basically the workflow that you schedule. You can put different triggers to it. And your CI/CD pipeline is like super short, actually. It's just to deploy that asset bundle thing, maybe modify the YAML definition of it a bit, but that's it. It's just much simpler than what we used to have on Kubernetes. On Kubernetes, when we were deploying things to Kubernetes, we first had a training pipeline. And when you have a training pipeline in the end, you create an artifact. And because of our security complexities, we had to download the artifact and embed it into Docker image. And every time you retrain the model, you have a new version of a Docker image. So it has to be tied together. And also, a new image needs to be created every time after model training ends. And then a new deployment needs to come because, the Docker image changed. And it was really annoying process, to be honest, to go through. So we really simplified it because now it's just one mode artifact, and from that you can, in the same workflow, actually create the deployment with Databricks. And for us, it became much easier.
So if you're creating those artifacts in your training, are those pushed directly to Databricks? I mean, if someone's not using a customized solution like Databricks, are they storing these in like an S3 bucket? Are there common workflows for these kind of things to be stored outside of a container image? Because I agree, like if you have to copy this thing into a container image with an additional build step, when you already have this set of files that you just need to store somewhere, like it does seem unnecessary to wrap it all up in a container image.
Yeah, no, exactly. So what we have typically is model registry tools. So we used to have our own back then when MLflow didn't exist. We just used JFrog Artifactory, where we put models and you could assign attributes to it, and that's how you can search for them and also download them. We basically misused it as model registry back then. But MLflow is now probably the most popular tool for model registries. That you could, you don't have to download it per se. It's just our security thing that we have to do, but you could just, access it directly via API. You could just, you don't have to download. You can just directly connect to registry from your deployment, potentially. So that makes it easier, but it's more error prone. So there are different considerations you can have there and different patterns that you can consider.
Yeah, it feels like that might also change if I'm updating some part of my infrastructure. If this artifact becomes part, if we think of this as part of the infrastructure for delivering a service, I'm just imagining a scenario where like now I have another thing that I need to monitor for change, or it's not a part of maybe my Git-centric workflows. So, my understanding is like a lot of the open source tools that we already use, Prometheus, Loki, stuff like that, I'm guessing that those are just extended to monitor this other deployment methodology?
Yeah, definitely. You can do that. Yeah, for sure. And ideally, just one tool that you want to have. And Prometheus and Grafana is also in MLOps world, I think, the most common combination, I would say.
Right.
It's just instead of just monitoring the health of your endpoints, you also want to monitor model drifts and data drifts in the same place.
Yes, less tools for everyone. That's a better thing.
So this is by far one of the most amount of questions I think I've seen in our chat. I think we might need to bring you back on the show.
We could go for hours on this.
Yeah, we could. So maybe we can take like one or two more questions, and then I'd like to make sure that we give some time to you, Maria, to kind of again reiterate where folks can get started on their MLOps journey, or if they're already on that journey, where they can find some more like advice and content and recommendation and all that.
I have selected one more that's kind of it's not out of left field, but it's different a little bit than a lot of the questions we're getting, which everyone's given excellent questions. So I apologize if we couldn't get to yours today. That's a rare problem we have. Can I be a Golang automation preferring SRE and help the ML engineers using Python? I just hate Python for CI/CD automation. How's Golang doing in the ML and AI world, or is it just Python?
Well, I think it's just Python mostly. I'm sorry. Now Rust actually is getting more popular, but Rust is kind of a thing now. But I don't believe it will take over Python. I also hate Python, by the way, in certain ways. I think installing Python or installing Python packages or building anything related to Python just causes so much pain to a lot of people. And I know that because I talk to data scientists, and they're not always tech savvy people, and they bump into the same problem, and it happens every year, like all the time. It just never stops, even with better tooling around Python. So I feel your pain. Yeah, I understand Python is probably painful to use sometimes, but no, Go is probably not really a thing in the community. But I mean, for CI/CD automation, if there is no one else and you could just go use Go for wrapping some things, like why not? I believe Dagger supports Go. It's one of the really cool tools for CI/CD, I believe. The problem with GitHub Actions or Azure DevOps pipelines is that you can't really reproduce them locally. So you have a lot of this try again type of commit messages. And with Dagger, you can just run things locally. And we tried it as well because we had a problem that we had to deploy in Azure DevOps and with GitHub Actions at the same time, similar types of workloads. So Dagger can be defined in Go, like why not?
Yeah.
There you go. Sorry about Go.
Yeah. I think Python, Maria, when you were doing your data science or you're doing your data science work, like it's the fast iterative nature of all the ecosystem and the community of everything. That's where everyone is doing they're implementing their research, right? They're doing the math, they're doing the work in that world. And so if you're using another language for that phase, you're always going to be behind the latest research because that's where everything is happening.
Yeah, for sure.
Right. To be fair, though, if you're a pure ops engineer and you're really focused on AWS infrastructure or Kubernetes clusters, or whether you're using Dagger or GitHub Actions, like if that's really your world and the data engineers aren't really involved with that at all, which in a certain size team they wouldn't be, you could still get away with, I hear Go is favored there, and I see a lot of activity in that world for just the ops automation, which doesn't necessarily to me affect the other software engineers that are making the code and making their app. So I've worked in teams that are Ruby and Python focused on non-ML workloads, and I needed to automate some infrastructure, and I would do that in Go or just shell script. And we never really needed to share that stuff. But of course, yeah, if I'm sitting with them and looking at notebooks and stuff like that, I probably am more on the engineering side of it. That's a great question at the end. Of course, like I have all these things we talked about today. It depends. And you do you. If your team is a Go team, like, hey, maybe you could be the first ones. But I love Nirmal's point of like, that's where all the science and all the great libraries are happening and all the tools. And so, you maybe just be a polyglot and just realize that's the world we live in. Maria, I sent a whole bunch of links. You can find her and the marvelous MLOps. Shout out to Marvel Comics. You can find all that stuff on LinkedIn, on Substack, other places on the web. But yes, Maria, thank you so much for being here. This has been a fantastic episode. We will surely have you back. And this is a very rapid moving world. So we could just pick one of 1,000 topics and probably fill a bunch of questions like this one. So thank you both for being here.
Thank you.
Yeah. And we'll see you next time. Thanks for watching. I'll see you in the next one.